Final review, Unit 2. When you're graphing, what's the one thing you should always make sure your equation is written?
Y equals mx plus b.
Very good. Okay, y equals mx plus b. Okay, what does m stand for? In regards to y equals mx plus b. Slope is the answer I was looking for. Okay, slope is also, what does slope mean? Very good. Rise over run, which is the change in y over the change in x. Since you guys are honor students here, change is actually a little triangle. That means change. Did you guys know that?
Yeah.
Delta, yeah. That means change. So it's the change in y over the change in x. If you want to think about it as your y value over your x value, that's fine too. All right, so on example 1, is it in the correct, oh, I forgot to talk about something else. The b. What does b represent? Your y-intercept. Okay, you should all know this, but we're just going to say it again to make sure. Remember that your up and down line is your y, and your right and left is your x. Whenever you go to the right, you are going a positive value, and when you're going to the left, you're going a negative. When you go up, you're going a positive value. When you're going down, you're going a negative value. Okay. So on example 1, is it in the correct form in order to graph it? No. What will I do? Very good. We're subtracting 2x. So now when I rewrite this, I have y is less than negative 2x plus 6 because we want it in y equals mx plus b form. What is the first thing you should graph? Your y-intercept, which in this case is 6. So we go up 6. 1, 2, 3, 4, 5, 6. From there, we use our slope. What is my slope? Good. Slope we always want to as a fraction, so we can write that over 1. So there is my slope. So from this point, I'm going down 2, right 1. Or we could have also gone up 2 and left 1, as long as one of them is positive and one is negative. That's good. Is this going to be a solid or dotted line? Good, dotted. Remember that less than or greater than is a dotted line, where less than or equal to or greater than or equal to is a solid line. Okay, so we have this as a dotted line. And then we also need to shade. Since this is saying less than, which way will we shade? Below the line. Okay? So you can think of it as left, down, below is less than. And that's it. Are we good? Yes? Okay, example 2. Okay, graph the solution to this. Notice we cannot put these in y equals mx plus b form. We just have an x value and a y value. So for my x, where will I go to graph this?
Left 4.
Very good. We're going to go on the x-axis, and I'm going left 4. 1, 2, 3, 4. Okay, now, will this line go up and down or right and left?
Up and down.
Good, vertical, up and down. And will it be a solid or dotted? And how do you know it's solid? Good. Okay, now shading. Do you think this one, greater than, will it shade right or left? Very good. Whenever I have 2 graphs or 2 lines on the same graph, I usually use different colors so I can see things, because the actual answer is where the 2 overlap, correct? Okay, so now for the y is less than or equal to 3, where will I go? Good, up 3. 1, 2, 3. And will this be solid or dotted?
Solid.
And which way will it go?
Horizontal.
Very good, horizontal is correct. And this says less than or equal to 3, where will I go?
Down.
Very good, down is correct. Less than is down. Do we see where they overlap?
Yeah, that little ball, like the fourth quadrant.
Very good.
Wait, was that the right term?
Well, the quadrants, like these are quadrants right here. But yeah, if you're talking about the actual graph, you could say that. Do you guys remember how they're numbered?
Is it like 1, 2,
1, 2, 3, 4.
Shouldn't the X go the other way? No?
The X is like, are you talking about the line? Or the shading?
Shading.
So it's saying greater. So think about which values are bigger. The bigger values are to the right. Positive values are right. Any other questions on example 2? All right, let's move on to example 3. Yes. Oh, I thought you said question. Okay, example 3. What do I need to do first?
Put it into y equals mx.
Good. Take this and put it into y equals mx plus b form. So we have 2x plus 3y is less than or equal to 12. So first thing I will,
Subtract 2x.
thank you, subtract 2x. We have 3y is less than or equal to negative 2x plus 12. Next, what will I do? Good. Divide by 3 is correct. And we end up with y is less than or equal to negative 2 over 3x plus 4. Okay, so if I graph this one, where will I go first?
Up 4.
Good. 1, 2, 3, 4. From there, where do I go?
Then down 2 over 3.
Down 2, right? 1, 2, 3. Or
You can go left.
up 2 and left 3. Good. 1, 2, 3. Notice that they all line up. Is this going to be a solid or dotted line? Okay. And which way will I shade? I'm going to shade down or under the line. Okay, next we have this line. Is it in the correct form? Yes. If there isn't a number in front of the x, what's actually there?
1.
A 1, and we can write that as a fraction by putting it over 1. Where do I go first?
Down 6.
Down 6. Okay. 1, 2, 3, 4, 5, 6. And from there I would go
Up 1 over 1.
up 1, right 1, or I could have gone down 1 and left 1, because you need to do negative, negative in order to make a positive. Okay, solid or dotted line? Okay, and is this one going to shade up or down? Or, okay, so it's up here. Do you see how that part is up? This is more of a positive direction where you're going to get positive values going up. Okay, do you see where they overlap? Whenever you have a line, any line, think about it as up and down. Unless it's this like thank you. Then you have to think of, oh wait a second, no I'm not thinking of that. The vertical line, then you have to think of right and left. Any other lines, think of them as up and down. Okay, yes? Okay, sure. Where are they overlapping? So always kind of make that one darker. Remember that on a multiple choice test, this would be the only thing that was shaded. Okay? All right, example 4. There's no graphing here. You're just going to be solving for x and y. These equations where you have x and y, you can use elimination, or you can use substitution, or you could graph them and find the exact point. Sometimes the points are fractions, so it's easier to use substitution or elimination. Do you guys want to use substitution or elimination? Okay, so if you're eliminating, notice how this is an x and this is a y. Is this an x? Is this a y? So I would change this equation so that x and y are on the left and your number is on the right. So let's go ahead and do that. So that means I am going to add 4x to both sides. And I'm also going to move the 7, so I'm going to add 7 to both sides. So now my x and y are on the left, and my number is on the right, and I'm going to write that as 4x plus 2y equals 7. And I still have this other equation right here, which is 2x plus y equals negative 4. Now, which variable will be the easiest to eliminate, do you think? Okay, so if I'm going to eliminate the y's, what will I need to multiply the bottom equation by? Okay. So I'm going to still rewrite the top, 4x plus 2y equals 7. And we're going to multiply the bottom by negative 2, and I get negative 4x minus 2y equals 8. Good. So the x's cancel out, the y's cancel out. When both things cancel out, that makes a 0 equals, and 7 plus 8 is 15. Now, a negative times a negative made a positive. 0 equals 15. Is that true? No. So this one is no solution. If we'd got 0 equals 0, then the answer would be all reals. This means that these are two parallel lines. They never intersect. There's never a point that these two lines cross. Okay. Questions? All right. Moving on. So now we have a word problem. Who remembers what we do on these? Two separate equations. It's your choice on variables, but I suggest using x and y. But again, it's totally up to you. So I'm going to choose that binders are x and pencils are y's. I'm going to go through, and wherever I see binders, I'm just going to write an x over it. And whenever I see pencils, I'm going to write a y. Again, it's totally up to you. You do not have to do it my way. So if I read my first equation here, it says 5 binders and 3 pencils cost $13.10. How will I write that as an equation? Very good. 5x plus 3y equals $13.10. What will my other equation be? 2x plus 6y equals, good, 6.20. So looking at our variables, which one looks the easiest to eliminate? The y's. And why do the y's look the easiest? Good, you only have to multiply that top equation, and we have to multiply it by negative 2 in order to make it a negative 6. So we get negative 10x minus 6y equals negative $26.20. And then I'll rewrite the bottom equation, 2x plus 6y equals $6.20. Okay, so my y's eliminate, which is exactly what I wanted, and negative 10 and positive 2 makes negative 8x equals, and here positive and negative, subtract, it's going to make what? Negative 20. Next, I will divide by negative 8 to both sides. 2 negatives make a, okay, now we could reduce this, but when you talk about money, do you normally say it in terms of fractions? So we should end up changing this to a decimal. So I'm going to divide 8 into 20. How many 8s go into 20? 2, and that's 16. There's 4 left over. So I'm going to add a decimal and a 0. And how many 8s are in 40?
5.
So that means that x represented binders. So binders equals $2.50. So now I still need to find pencils. Which equation do you think would be the easiest to use? Good. So if we do the 2 binders and 6 pencils, if I take 2 times 250 plus 6y equals 620. What's 2 times 250? Very good, $5. So I have $5 plus 6y equals 620. Then what? Good, subtract the $5. Okay, so I end up with 6y equals $1.20, and then last we divide by 6. Some of you can do this in your head. Some of you might want to do long division. 6 goes into 120. We have to bring up the decimal. 6 goes into 12. 2 times, that's 12. 0 left over, bring down the 0. 6 goes into 0. 0 times. So that means my answer for pencils is 20 cents. That's not the answer? That is the answer. Because they want to know the cost of binders and pencils. Okay. Are we good? All right. So then we have our X, Y, and Z equations, which I know you all love. So remember that the object is to eliminate one variable from 2 different sets of equations. So if you look at these, if you're looking at X's and Y's and Z's, which variable looks the easiest to eliminate? Y's. Okay, good. So let's add, if I add the first 2 equations together, it's going to eliminate the Y's, right? And I don't even have to multiply by anything. Do we see that? Okay. So let's go ahead and do that. Can we do that without rewriting it?
Yes.
Okay. So if I'm adding the first 2 together, I get 6x, the Y's cancel, plus 12z equals 18. But I need 2 equations that have 2 variables, right?
Yeah.
So I can't use the same 2 equations. We have to use the last one. So what 2 equations should I use? Good, the last 2. And again, I won't have to multiply by anything. I can just add those together and eliminate the y's. So when I add those last 2 together, I get 8x plus 16z equals, okay. So now I have my 2 equations with 2 variables. So now I have to eliminate it, so I just solve and get 1 variable, right? So is it going to be easier to eliminate the x's or the z's here? Okay, so what am I going to make them equal to? 24. So I'm going to multiply the top by 4 and the bottom by -3. Okay. So when I multiply through by 4, I get 24x plus 48z equals, and 18 times 4 is 72. Very good. Then we multiply the bottom by -3. I get -24x minus 48z equals -72.
Okay, so 0 equals 0, so all reals.
0 equals 0, all reals is my answer. Which means that all 3 of those lines end up being the same line. They're right on top of each other. If not, you would have ended up getting like z equals something. Then you'd plug it into one of these and get the answer for x. And then you'd take both of those values and get your y.